Thank you so much, Chad. And I can't explain how really excited I am to be here in such a large room full of people who are all interested in this idea of local first and all want to help make it happen. So thank you so much for, as Chad said, being pioneers and being part of this movement. I would like to talk a little bit about where local first came from, at least from my very subjective perspective, do a bit of discussion about where I think we are today in terms of understanding the state of things, and then where I hope we can all work towards in the future over the coming years. So starting with the history, my personal background and how I came to this topic starts over 10 years ago. So back in 2011, Mark Shapiro and his colleagues published this research paper on conflict-free replicated data types, or CRDTs, which, if you haven't heard about them, don't worry, it's kind of not really central to the discussion here. But for me, that was kind of the starting point, because at the time, I was working in industry, but I was a bit frustrated with the state of how we were building software for the web, and software as a service and websites in general. And I was looking around for technologies that would help make things better. And I came across this paper maybe in about 2013 or so. I don't remember precisely when. And I thought, this is interesting. There seems to be the core of something here. I couldn't really articulate it very well yet at the time. But I wanted to start working on that properly, so I left my job in industry. I took some year out as a sabbatical and then moved into academia. And I started working with CRDTs. I started writing my own CRDT-based text editor in Ruby, as it happens, because back in 2015, that was still a language that some people used. But I'm sure some people still use it now. Sorry. I don't mean to be looking down on anyone at all. And so it was a terrible piece of software. It took 2 minutes to save a file after you had edited, but it was sort of a starting point for all of this. And then about 2017, the folks at Ink and Switch got in touch with me and said, well, you have this nice theory work on CRDTs, but should we try building some software that actually works with it? And so I got together with them, and we built this library called AutoMerge, which was initially in JavaScript, and then I maintained the JavaScript version for several years, but then eventually rewrote it in Rust, and other people are now maintaining that, and I'm just more of an advisor to the project. But through all of this time, we were lacking an adjective. We wanted some adjective to describe. I am building an X-type app, where X somehow represented the values and the principles that we were trying to embody in these technologies. So it wasn't really about the technology per se, it was about these values we were trying to represent in our software. And so, after a bunch of thinking, we came up with this term that we called it local first. We considered a bunch of alternatives as well. But this seemed to be like the best we had, and we wrote this essay, which probably many of you have seen. So I'm not going to recap the whole thing, but that came out pretty much exactly 5 years ago. And in this, we tried to articulate what we thought was interesting about this new way of building software, and some of the benefits that it would bring, certainly from the end user's point of view. And then in the last 5 years, of course, things have continued. So as I mentioned, AutoMerge got rewritten in Rust. It became production ready. We continued adding more features, etc. I'm not really going to talk about AutoMerge in this talk. Alex Good later today will be giving more of an update on AutoMerge specifically. But another thing that happened over these years while we were working on our little project was lots of other people were also working on all sorts of other projects related to local first. And this is not a comprehensive survey by any means, but I've just tried to pull out at least a bunch of software projects that mention local first on their website, and so self-describe themselves as local first. Or some of these don't explicitly describe themselves as local first, but I think are sufficiently aligned in terms of philosophy that I put them on here anyway. And this is just to show that it's actually become a real movement. It's not just a small group of us writing academic papers and doing a bit of theory, but this is actually a very much real thing, and it has grown tremendously over the last 2 years. And so this has then, however, opened a lot of questions, and in particular, as people have joined the community, they've asked very reasonable questions, like, what exactly do you mean with local first, actually? The term offline first had already been around for a long time. It predates local first by at least 6 years or something like that. And obviously, we were aware of the term offline first when we coined the term local first. And the reason we coined a new term was because we wanted to express something new, something more than offline first, which was not captured in the term offline first. And so I will go into that in a moment of what I think that additional bit is. Some people seem to think that local first is just like software that uses CRDTs, which is one way of looking at it, but that's kind of too narrow in my opinion, because CRDTs are just one technology, and you could use other technologies as well to create local first software. Some people think that local first means it has to be peer-to-peer networking and you can't have any servers at all, which again I think is not really the right answer either, but we'll get into that. In terms of our attempt to define what local first is, what we did in the original local first essay was we articulated these 7 ideals, and the idea, what we were trying to do at the time to think, well, if you ticked all of those 7 boxes, then you can qualify as being local first software, but you could also imagine it, being a somewhat of a gradient where there's a gray area of being like somewhat local first, but maybe not satisfying all of these ideals. We've now since then come to realize that actually these 7 ideals aren't really a good definition of what local first is. These 7 ideals are actually more the benefits that local first can bring, especially from the point of view of an end user, but it's not really a crisp definition that allows you to say, like, is this piece of software local first or not? And so we've realized more recently that there's a need to articulate more precisely what it is we mean. And I want to propose one such definition in this talk. And we'll probably do a follow-up to the local first essay sometime soon as well to have it in written form. The definition I will propose is potentially up to some debate, and people might reasonably disagree with what I will propose as a definition. But this is sort of what we've come to, we being the people who originally published the local first essay and among discussions among ourselves. And so as a way of introducing the new definition, I want to bring up Leslie Lamport. Some of you might have heard of him. If you're a distributed systems nerd, you probably will have heard of him. He won the Turing Award back in 2013, I think, for his work on distributed systems. And he has this old quote, like, being from 1987, in which he said in an email, a distributed system is one in which a failure of a computer you didn't even know existed can render your own computer unusable. May sound familiar if you've ever tried to get something done while GitHub was down or while AWS was having a hissy fit or something like that, and half the internet doesn't work. And so this is kind of, in some sense, a good capturing of what we were trying to get at with local first. And definition I will propose is that in local first software, the availability of another computer should never prevent the user from working. It should never block the user. So let me unpack a little bit what we mean with that. Firstly, one aspect of local first is that it's not local-only software. So if it's traditional desktop software which only stores its data in files on the local disk and doesn't actually use the internet at all, it's sort of local first in a technical sense, but it's not what we really talk about here. So what we think is an important part of the definition of local first is that it's multi-device software, at least. There is some sort of data syncing happening from one device to another. This might be between different users who are collaborating on some data, or it might be a single user software, but with the user having multiple devices and syncing the data between their own devices. But so I would say that this, having it multi-device is definitely a prerequisite for qualifying as local first software. Secondly, I said the availability of another computer should not stop you from working. So availability here includes the network. So if your network is down, or if your Wi-Fi is off, or you're somewhere in a tunnel underground where you don't have cellular data reception, if the software does not just continue working, then it's not local first, in my opinion. And so that means offline first is a part of local first. You can't be local first without being offline first. But that alone, I think, is not sufficient to qualify as local first. And the final bit is this. So in my opinion, and there might be some debate about whether this is the right definition, in my opinion, if the software doesn't work even if the original developer of the software goes out of business and shuts down all of their servers and stops paying their AWS bills, then it's not local first. So in other words, what we're trying to get at here, thank you. What we're trying to get here is robustness not only against availability in the network sense, where the network is down, but availability of another computer in the sense where that computer actually fails because it's got shut down and it's deleted all of its data. So you might be familiar with this ancient Tumblr blog called Our Incredible Journey, which still exists and still seems to be updated, in which startups that have just got acquired and that are going to shut down their product in 3 months' time wax lyrical about, oh, thank you, users, you allowed us to have such an incredible journey building this startup and selling it, and now we're going to screw you all by just deleting all of your data in a few months' time and giving you, if you're lucky, a zip file containing a bunch of JSON to download, which you can't import into any other software, and so, well, good luck with that. So, and so I think this is really part of what motivated local first, and we didn't do a very good job of explaining this in the original essay, which is why I want to really emphasize it now. Incidentally, it also shows why CRDTs in themselves are not sufficient in order to make local first. If you look at the top item here that is posted there, that is the shutting down of a service called Skiff, which got acquired by Notion. Skiff was like this end-to-end encrypted Google Docs equivalent. It was built on YJS, a very good CRDT library, but that didn't stop them from appearing on Our Incredible Journey when they decided to get shut down. So it seems you need more than CRDTs. You need the entire application architecture to be built accordingly. Of course, it's not just startups getting acquired. Big companies shut down products all the time as well. So another website you might have seen is this one, Killed by Google, which catalogs almost 300 products that Google has shut down over the years, including some very beloved ones like Google Reader, you might remember. So what we've been doing is calling this making apps incredible journey proof. What we want here is that somehow at a fundamental level, the architecture of the software is resilient against the creators of that software just disappearing. And in particular, it means the users shouldn't lose any data, but also, as far as possible, the functionality of the application should continue working even if any servers related to the application disappear. And so this is a bit of a challenge because if you want to synchronize between two devices, there's usually a server involved in the middle somewhere. And well, if this server is a proprietary server that only the makers of the software can run because only they have the code to do so, that's not really local first in my opinion because there's no way for users to recover from the failure of that server. You can improve things a bit by at least having an open source server that people can self-host. And it's not really a great solution because self-hosting it's only accessible to people with the appropriate technical skills, which is already a very small fraction of the population. And then even among the people with the technical skills, like in principle, I could self-host a server, but do I really want to? Like, I don't want to be in the business of running servers. I have better things to do with my life. So I feel that self-hosting it's a small bit of an answer, but it's not really a complete answer to making software incredible journey proof. Another thing that people propose is peer-to-peer networking, and in theory, this is really appealing because peer-to-peer means that you can just connect two devices or multiple devices and have them synchronize some data without involving any servers at all, or maybe just involving some general-purpose DHT in the sky or something of that sort. But the practice is it's actually still really difficult to make peer-to-peer software good. This is something that a lot of people have put a huge amount of effort into, and I think it's still an unsolved problem. Part of it is just the fact that the two devices have to be online at the same time in order to talk to each other. That's kind of a fundamental thing. But then also partly just because of the way the internet works nowadays, and there's NAT and firewalls and all sorts of things that get in the way of establishing peer-to-peer connections. And so you need these elaborate dances like signaling in order to introduce the two devices to each other, but then you need a server in order to do that signaling. And then also, if you want to then be robust, you need some sort of fallback in case the direct connection between the devices fails. So you need a turn service as well. And now you've got these servers for signaling and turn, which then raises the question of, why don't you just use those servers to do the actual data synchronization anyway? If you've got servers anyway, you might as well use them. So my feeling is that maybe peer-to-peer will get better with more people working on the technology, but right now it seems to me that it's a lot of complexity for fairly little benefit. But what we could do maybe is to rely on other services. So you could imagine, for example, that you have your local first app, say it's a local first spreadsheet or whatever, and it stores its data not on your own servers, not on the app developer's servers, but in some general purpose cloud storage service like Dropbox or Google Drive or iCloud or whatever you like. This is not really ideal as well for a number of reasons. In theory, of course, that cloud service could also go away, although I have higher confidence that, say, Google Drive will still exist in 10 years' time compared to your random two-person startup's custom service still existing in 10 years' time. I don't mean to underestimate your ambition or anything like that, but just looking at prior experience, that's hopefully a fair assessment. Another thing is also that all these cloud storage services are really file storage services, so they don't really work very well for real-time collaboration. If you want to see other people's cursors and mouse positions in real time and so on, then doing that sort of thing via a file storage server doesn't really work very well. But it seems to me like this is more a promising direction. This is a thread that we can pull on. So what about this? As a longer-term vision for where local-first software should go, and this is, I think, where we move to the future part of the talk, is consider you have a number of local-first apps written all by different software developers. So maybe there's a local-first spreadsheet, and a graphics app, and some sort of task management app, and many other apps. And a user has these apps installed on their phone and also has these apps installed on their laptop. And so now you need some sort of synchronization between those. But part of the idea of local first is that all of the interesting logic lives on the client side in the user's app, in the software that actually runs on the user's devices, which means that any synchronization that happens between them should be like a really simple matter. It should be just a matter of getting some bytes over the wire from one device to the other device, because you shouldn't be doing any sort of business logic or anything particularly complex in the server anyway, if you want all of the software to continue working offline locally on the user's client, which suggests that it should be possible to have a generic syncing service that can be used by a whole bunch of different applications. And now this is where things get really interesting. The syncing service here, it doesn't exist yet, but this is why I'm talking about the future. The syncing service should be able to exchange the data, perform the synchronization, regardless of the data model and the file types of the applications on top of it, because it should be a fairly simple protocol that is just moving some bytes back and forth. And in fact, what I will hope we will move towards is, as we figure out what the syncing service should look like, we can actually standardize the protocols that the syncing service uses in such a way that it's app independent and that a large community of people agrees on, this is a good general purpose protocol to use. And then we can have multiple different implementations of that protocol made by different people, and they can all interoperate with each other. And you should be able to then take a local first app that is maybe currently pointed at one particular syncing service, say in some hypothetical future, AWS runs a syncing service for local first apps, just in the way they run S3 today. And if you want to sign up for that, you can pay AWS a small amount of money, just charge it by the gigabyte as they do for S3, and point your local first apps at that syncing service. But if something happens, if whatever, Amazon decides to shut it down or change it in some way, or just decides to make it too expensive or whatever, you should be able to just point your apps at the equivalent service run by Azure. And if they're following an open standard protocol, you should be able to just point your app to a different service by just changing a single configuration flag in your app, and everything else should just continue working. And the app developers, in particular, don't need to worry about which syncing service you're using, because it has then just become this commoditized piece of infrastructure. So the interoperability between different syncing services is what makes this valuable then. And because all of these different syncing services can speak the same protocol. And if we have this general purpose syncing service, now it makes sense to add peer-to-peer into the mix again. Because I think peer-to-peer is amazing when it works, especially, for example, if you've got two devices sitting right next to each other on the same table. It's ridiculous that all of the data synchronization should go via AWS US East 1 in Virginia, when in fact you've got them sitting right next to each other, okay? So using the local network when it's available, or opportunistically using peer-to-peer networks, even over the internet, when they're available is great, as long as it's just not relying on that as the sole syncing mechanism. And then this again provides additional robustness, because the situations in which the cloud service fails will probably be different from the situations in which the peer-to-peer sync fails. And so if we can have both, well then we just gain robustness overall. We gain robustness against both peer-to-peer failures and cloud service failures. So this seems to me like a very promising way of achieving this goal of being incredible journey-proof, to have multiple interoperable sync providers. Now, obviously, we're not there yet, and I'm not pretending we are there, but this is something that I hope we can work towards. Now, I think this architecture in which we make this synchronization service for local first a kind of piece of commoditized infrastructure has a huge set of benefits for not just the end users, but also for the people developing the application software. And this is another piece that we missed in our original local first essay 5 years ago. That essay focused very much on the benefits from the point of view of the end user, which is important, but since then we've come to realize that actually the benefits to the app developer are perhaps at least as big as those to the end user. One of the really big ones is that as an app developer, if you adopt this kind of architecture where the syncing service is just some general purpose piece of infrastructure, is the app developer doesn't need their own back-end engineering team anymore. This is a huge amount of complexity that currently startups have to take on in order to build not only the user-facing parts of their product, but also hire a bunch of people who can write cloud services and who know how to operate AWS's weird configuration and who know how to do DevOps and all of this stuff. In particular, all of these back-end people who then have to take shifts for on-call rotation to be available 24/7, because, again, if all of the back-end is just somebody else's problem, then, you as app developers just don't have to worry about it anymore. And I think this is a huge deal, because it means then app developers can focus on the parts of the app where they are distinctive, that is, the building really good user interfaces and user interactions, and making sure that the purpose that the app is serving, the end users are very well served by the app they are building. And none of that is specific to building backend services. The backend service is an entirely separate concern, and you can have a separate team that then specializes in running a really good syncing service and providing that as a service to the rest of the ecosystem. Another benefit to app developers with the local first approach is that actually just the app development model becomes a whole lot simpler compared to the traditional approach of building cloud software. Because with cloud software, you're constantly making these network calls from the browser to the back end, and you have to worry about what if the user is on a spotty Wi-Fi, and so the call times out, and then how do you communicate that back to the user? And actually, we've seen again and again with people building local first apps, one of the things they love about it is that they don't have to write all of this network error handling code, because the synchronization protocol is, again, just runs in the background. It's a piece of off-the-shelf infrastructure. You just pick a library off NPM and you're done. And you as app developers don't have to worry about that. And then finally, of course, you as app developers don't have to worry about paying for cloud services if this is a separate service that the that the users sign up for directly. So overall, it just gives us this picture of app development becoming radically simpler, and that really changes the whole economics of software development, and that is perhaps one of the deepest effects I think that I think local first is going to have. It's not about a particular technology, it's about changing the economics of software, allowing smaller teams to get more done, and building more impressive apps with fewer people, and therefore with less capital. And so that then has a whole bunch of exciting implications. It becomes economically feasible for smaller teams to build really niche apps that serve a small number of users really well. And that's fine, because even though those smaller number of users won't generate a huge amount of revenue, but if you're not trying to build a venture-funded, huge, hundreds of millions of users type app, if you can build something with a small number of people, it's fine to have a small user base, but that finds the product really valuable. And also, it seems to work very well for prototyping as well. So we've seen people build impressive prototypes of collaborative apps within a week or so using local-first technologies, and a lot of that is down to just the programming model being so much simpler. Now, the biggest challenge that I see for local first for the future is also an economic one. And so the counterpart here to this opportunity, I think, is whether the business model, the traditional business model of software, will still work in the local first era. I think and I hope that it will, that in some sense you can just say it's the same business model as SaaS. You pay a subscription. But of course, with the traditional model of SaaS, app developers have this gun that they can point at the user's head and say, you have some nice data here. It would be a shame if you lost all of that data, wouldn't it be? So how about you pay up and pay your subscription so that we don't go and delete all your data? And of course, in the local first world, if you're following this idea of being incredible journey-proof, then that doesn't work anymore because the users can just take their data somewhere else. So what is in startup jargon called the moat, the data moat, is weakened in local first software. It might be that that's not a problem. It might be that actually we can just say, we're selling software on the basis of the value that it provides to users, not on the basis of holding users ransom. But I hope that will be one of the topics for discussion today of how we can bridge the economics and these challenges. So in terms of the technologies for actually making this, obviously I mentioned that I've been involved in the AutoMerge project for a long time, but there are many other projects as well, and I'm very open-minded to lots of people building different technologies, and I think that's a great thing that there's such lively activity in this ecosystem, because I think that the simple answer is we don't know yet what will work and what won't work, and so we need those 1,000 flowers blooming so that we can just gain experience of different approaches and understand the trade-offs better. So I'm really excited that so many of you are helping build this ecosystem and trying lots of different approaches and experimentation. I think right now it's too early to go to the IETF and start standardizing the protocol that we can use for this generic syncing service, because right now I think we don't understand the trade-offs well enough yet. But I think in a few years' time we will understand it, and then at that point we can start founding our standardization committee and stuff like that. So I think we will get to that. But fundamentally what I want to get across is that local first is a set of principles and values. It's not any one technology, but I do believe that these principles and values lead us to a better way of building software in the future. And this is really the core of it, to leave you with this, that we want to make sure that the users can always continue doing their work, regardless of whether they have an internet connection and regardless of whether the servers of the software developer disappear. We want it to be incredible journey-proof as well as being offline capable. That's it from me. Thank you so much for listening, and enjoy the day.
Excellent talk and amazingly inspiring.